class. Thank you for joining me today for another class on painting. Today we are going to be talking about color theory and just getting a basis for color theory. In color mixing for painting, the fundamental rule is that there are three colors that cannot be made by mixing other colors together. These three, red, blue, and yellow, are known as the primary colors. If you mix two primary colors together, you create what is called a secondary color. Mixing blue and red, for instance, creates purple. Most people know these, but I'll give you a rundown anyway. So, blue and red creates purple, red and yellow make orange, yellow and blue make green. The exact hue of the secondary color you've mixed depends on which red, blue, or yellow you use and the proportions in which you mix them. If you mix three primary colors together, you get a tertiary color. Now, black and white can also not be made by mixing together other colors, but as they aren't used in color mixing to create colors, they get excluded from color mixing theory. If you add white to a color, you lighten it, and if you add black, you darken it. Though some painters don't use black at all. You can buy various different blues, reds, and yellows. For example, blues include cobalt blue, cerulean blue, ultramarine, monosteel blue, and Prussian blue. Reds include alizarin crimson or cadmium red, and yellows, cadmium yellow medium, cadmium yellow light, or lemon yellow. These are all primary colors, just different versions. Now, which specific primary colors should you use? It's not a question of there being a right or wrong primary color to use, but rather that each blue, red, and yellow is different and produces a different result when mixed. Each pair of primaries will produce something different. Sometimes it's only subtle, but there is a difference nonetheless. So let's see here. Let me look at my notes. Let's talk about warm and cool colors for a moment. Every color has a certain bias towards what's called warm and cool. It's not something that's overwhelming. It's subtle, but it's an important element in color mixing as it influences the results. As a group, reds and yellows are considered warm colors and blue a cool color. But if you compare different reds or yellows or blues, you'll see that there are warm and cool versions of each of these colors relative to the other only. For example, cadmium red is definitely warmer than alizarin crimson, though alizarin crimson will always be warmer than, say, a blue. Now, the reason you need to know about warm and cool colors is this. It's important to recognize that individual colors have a bias toward cool or warm for color mixing. If you mix two warms together, you get a warm secondary color. And conversely, if you mix two cools together, you'll get a cool secondary. For example, mixing cadmium yellow and cadmium red light creates a warm orange. If you mix lemon yellow with alizarin crimson, you get a cooler, more gray orange. Mixing secondary colors is not only about the proportions in which you mix the two primary colors, but also knowing what different reds, yellows, and blues produce. You understand? Any questions on that? Okay, then we'll move on talking about secondary colors here. Secondary colors are made by mixing two primary colors together. Red and yellow to get orange, yellow and blue to get green, or red and blue to get purple. The secondary color you get depends on the proportions in which you mix the two primaries. If you mix 3 primary colors together, like I said, you get a tertiary color. I'm sorry, my pronunciation there. Secondary colors are made by mixing the 2 colors together. So let's see. Red and yellow will always make some kind of orange. Yellow and blue, green, blue and red, purple. So, like I said before, the actual color you get depends on which primary you're using. Now, the proportions in which you mix the 2 primaries is important. If you add more of one than the other, the secondary color will reflect this. For if you add more red than yellow, you end up with a strong reddish orange. If you add more yellow than red, you produce a yellowish orange. Experiment with all the colors you have and keep a record of what you've done. That's the best way to discover, what you like, what you need when you're painting. Color mixing gives you a range of colors with a minimum number of tubes of paint. It's very useful when you're painting outside your studio. If you're using a lot of a certain color, you'll probably decide it's easier to buy it in a tube rather than mix it up again and again. But you'll find there'll always be an instance when the color you want simply doesn't come ready-made, such as a particular green in a landscape or such. Your knowledge of color mixing will enable you to adapt a ready-made green to the shade you require. The advantage of buying a pre-mixed color is that you're assured, most of the time, of getting the identical hue each time. And some single pigment secondary colors, such as cadmium orange, have an intensity that's hard to match when you mix it by hand. The browns and grays contain all 3 primary colors. They're created by mixing either all 3 primary colors or primary and secondary color. The secondary color, of course, being made from 2 primaries. By varying the proportions of the colors you're mixing, you create the different colors. Mix a primary color with its complementary color is the easiest way to make a brown. So add orange to a blue, purple to a yellow, or green to red. Each of these makes a different brown, so once again, make up a color chart to give you a quick reference to refer to until you have that in mind. The easiest way to mix up gray is to mix some orange or yellow or red with the blue and then add some white. You'll always want more blue than orange, but experiment with the amount of white. You can also mix the blue with an earth color, such as raw umber or burnt sienna. Of course, with watercolor, you don't have white paint. To lighten a gray, you add more water instead of white. But remember, the gray will be lighter when it dries. So, when you're trying to make the tertiary colors, sometimes they can be muddy, so you have to watch that. If you mix too many colors together, you'll get mud. If your gray or brown isn't coming out the way you want it to, rather start again than add more color in the hopes that it'll work. It's always an easy thing to do, just start again. The complementary color of a primary color is the color you get by mixing the other 2 primary colors. So, the complementary color of red is green, of blue is orange, and of yellow is purple. So, does that make sense to you? Yes. Okay, so the complementary of a secondary color is the primary color that wasn't used to make it. So, the complementary color of green is red, of orange is blue, and of purple is yellow. That's pretty much what I just said, reversed. Now, complementary colors are important in color theory because when placed next to each other, complementary colors make each other appear brighter and more intense. The shadow of an object will also contain its complementary color. For example, the shadow of a green apple will contain some red. Now, I know you're thinking, how am I going to remember this? Aside from the notes that you're taking, or that I'm assuming you're taking, the color triangle makes it easy to remember. The three primary colors are in the corners. The color you get by mixing the two primaries is between them. The complementary color of a primary color is the color opposite it. So I recommend, I'll give you the link here, but go to this website and you can actually print out a color mixing triangle worksheet and paint it in. It's a simple exercise and it seems like it's hardly worth spending time on, but it's the first step in a fundamental painting skill, successful color mixing. And then you can put it up on the wall where you can see it at a glance until you've internalized which colors are primaries, secondaries, and so forth. Now, what happens if you mix complementary colors with one another? You get a tertiary color, particularly browns rather than grays. Now, using black and white. While it may seem logical to lighten a color, you add white to it, and that to darken it, you add black, this is an oversimplification. White reduces brightness, so although it makes a color lighter, it removes its vibrancy. Black doesn't so much add darkness as creates a murkiness, though there are instances in which black is uniquely useful, such as the range of greens it can produce when mixed with yellow. Adding white to color produces a tint of that color. It makes a transparent color opaque and cools the color. This is most noticeable with red, which changes, of course, from a warm red into a cool pink when you use titanium white. You can add white to lighten a color, but like I said, this removes vibrancy of a color, and you'll end up with a washed-out picture if you use white to lighten all your colors. And rather than develop your color mixing skills to produce hues of varying intensity, for example, to lighten a red, add some yellow instead, then white. Or try zinc white. Watercolor paints are, of course, transparent, so to lighten, you simply add more water to paint to let the white of the paper shine through. Let me see here. Now we're going to talk about why you should avoid black when you're doing shadows. A lot of people think that is the way to go. Think again. And now you think about how much how much is truly black in nature. Shadows are not simply black, nor are they a darker version of the color of the object. They contain the complementary color of the object, like I mentioned before. Take, for example, the shadow on a yellow object. If you mix black and yellow, you get an unattractive olive green. Instead of using this for the shadow, use a deep purple. You're going to have to trust me on this until you get to try it yourself. Purple being the complementary color of yellow, both will look more vibrant. If you can't figure out what colors are in the shadows, simplify what you're looking at by placing your hand or a piece of white paper next to the bit you're having trouble with, and then look again. Painters have used black. At various times in their careers, the Impressionists didn't use black at all. Take Monet's paintings of Rouen Cathedral, in the morning full sunlight, in dull weather, and in blue and gold to see what a genius can do with shadows. He did 20 paintings of the cathedral at different times of the day. It's not true to say the Impressionists never, ever used black, but they certainly popularized the idea. Or, if you can't see yourself working without black, then consider mixing up a chromatic black rather than using a straight from the tube black. It also has the advantage not killing a color it's mixed with to the same extent. So, now, different pigments have different covering properties. Some are extremely transparent, barely showing on top of another color. Others are extremely opaque, hiding what's beneath. Considering this, and not just what the color is, can enhance a subject. For example, using a transparent blue in a sky gives a greater feeling of airiness than an opaque blue will. Compiling a chart of the colors you regularly use, such as the one that I have up here on the board, shows at a glance how transparent or opaque a color is. So to make this chart, you will need all the colors you usually paint with, a medium-sized brush, a cloth to wipe the brush on, a jar of clean water, a pen to record the color names, a piece of white paper. If you've got about a dozen papers, you're going to want a sheet about A5 size. A ruler, that's optional. Straight lines aren't essential. That's just what I've done up there. And a hairdryer is optional to help dry the colors. You just want to sort your colors in an order that makes sense to you, such as using the color spectrum, the rainbow. Mix up a little of each color, paint a vertical stripe of each, and wait for them to dry. Then you paint horizontal stripes for all the colors in the same order. If you're using a ruler, wipe the edge after each stripe so you don't contaminate the next one, of course. And then you record the names of the colors next to each stripe. Now, when it dries, you check the results. Opaque pigments are dense and tend to block out other colors. This makes them ideal for subjects that are solid and heavy, such as tree trunks. And transparent pigments are light and airy, barely showing on top of the other colors. This makes them ideal for atmospheric subjects such as a misty morning or diaphanous fabrics. Semi-transparent are somewhere between the two. Now with time, you won't have to refer to the chart, but will instinctively know the properties of a particular color. But until then, stick with the chart up on the wall there, where you can see it while you're painting. So it never hurts to have, all this information. Any questions on this, or? Okay. No, that's fine. If you have any questions, feel free to email me. And otherwise, I will see you at the next class. Thanks. Have a great day, guys.